Okay, let's be real. Graphs can be confusing. What is the difference between a bar chart and a box plot? Also, when people talk about average, what do they really mean? Does that tell the full story? In this video, we'll break it down step by step using real data in R. I'll show you how to make histograms, box plots, and bar plots. We'll also learn the difference between mean, median, and standard deviation using simple visuals, very little formulas. Why should you trust me? My name is Bogdan Popescu, and I'm an assistant professor of political science at John Cabot University of Rome. I have years of experience of teaching statistics, but I also frequently use quantitative approaches in my articles and books. Let's dive right in. Okay, so this is visualizing data distributions in R. So we're going to learn how to produce histograms and how to explore distributions based on data that we're loading into our computer's memories. We're going to create bar plots that show distribution, that show frequency tables. And then we're going to create line plots that examine trends over time. Okay, so before we start, we're going to open a new Quarto notebook. This is what your R interface should look like. We click on New File, Quarto Document. This is what the next step entails. We're going to label our Quarto document notebook. Of course, you're welcome to call it whatever you like. And this is what we should see. So this is what the default code looks like in a Quarto document. We're going to press Visual, and we're going to move to Source. So this is what is going to allow us to see the original code. We want to interact with Quarto directly. So we're going to get rid of everything that's written in the default notebook. We're going to press Command A or Control A on a Windows, and we're going to delete everything. So we're going to start with a clean slate. So this is what the R interface looks like. For now, we are going to copy and paste this code. So if you click on this code, if you click on this symbol, you're going to be able to copy and then paste this preamble or YAML header. So you have to place it here at the very beginning. Make sure that there is no space at the beginning. So the very first line are the 3 dashes, and the 12th line are again the 3 dashes. So this is the beginning and the end of the preamble document. If you simply paste that code into the Quarto document, you're not going to have any issues. But if you want to type it down manually, then you might run into either formatting problems or into problems related to spacing. So make sure that your preamble or your YAML header looks pretty close to this. Okay, we're going to now save the notebook. We simply click on the floppy disk symbol. We're going to save it within our working directory. In my case, this is a folder called example. And then we're going to relabel it. So I'm going to call this notebook. Okay, now we're going to render this Quarto document. If we render it, this is what this is going to look like in Safari or Windows Edge. So we have a very simple generic title called Notebook. We have the author name. Of course, I strongly encourage you to change this to your own name, and then the date when you produce this document. Okay, we're going to now add an R chunk. We can do this by simply clicking on the green symbol. This is going to open up a new menu that's made out of all these different programming languages. But this is an R course, so we're going to click on the R logo, which is going to produce this section, this gray section, which is called an R chunk. So the distinctive features of this chunk are the 3 apostrophes that it starts off with, and the 3 apostrophes that come at the end. This is code that run will see and run. Okay, now we're going to add text outside of this chunk. So this is going to be at the beginning. So we're going to add a header called introduction and a simple text right after. Notice So first, before we notice, we're going to render the document to just get a sense of what this looks like. So if we render the document, we notice the same title notebook, but now we notice a section name, which is called Introduction, a section name which also appears on the table of contents. Okay. In order for this introduction to appear as heading, as a section title, it has to be the case that there is a space between the hashtag and the title. Okay, before we get into the real work, we're going to first remove everything that we might have loaded up previously. Datasets, lists, different vectors. So the way we do this is by simply typing in rm list equals ls parenthesis parenthesis close parenthesis. So this is going to remove everything from memory. Okay, we're going to work with the previous data sets that we worked with, life expectancy and urbanization. This is data that's collected from our World in Data, which itself collects data from the UN. We're placing these in a separate folder, in a working directory. In order to identify our work directory, I encourage you to use file choose. This is going to allow you to manually interact with R in order to load up the document. If you do this, you're going to come up with a file path, right? So this is going to be different for your computer. If you use file choose, you're going to be able to see this file path, which will allow you to paste it here. The next step is to just read the CSV file. I simply use read.csv and then the file path. And then the same for urbanization. Okay, so this is what the two data sets should look like in the environment. So we have a data frame or a data set with 20,445 observations and another one with 14,021 observations. Notice also that the file path is saved here as a value. Okay, let us calculate the average life expectancy by country code. This is something that we have covered already. So I'm creating a new data frame called life expectancy 2. I'm grouping by code, and then I'm calculating the mean called life underscore x underscore mean, which is the average life expectancy per country. I'm doing the same for urbanization, very similar to before. And then I'm getting rid of weird labels. If you remember from the previous video, we have some countries that have weird country codes. Normally, every country should have a 3-letter code. But in our sample, we also have some countries that have labels like this, OWIDKOS, or OWIDWRL, or nothing. So the reason why we have these kinds of data with these countries is because some of the countries or continents have aggregate level data. For example, you have life expectancy for Austria, life expectancy for Afghanistan, but you might also have life expectancy for Africa. So we do not want to include those observations in our analysis. So this is the point of this step. In addition, there might also be some countries that are not fully recognized by the UN. So that's why they have longer titles or longer country codes. So this is what we're doing in the next step. We're trying to eliminate them, get rid of them. And then we're doing the same thing for urbanization. Finally, we perform a left merge. So this means that we're placing urbanization data onto life expectancy. We're merging the two data sets by code. Okay, we're also removing NA values. If you remember from last video, we might have some NA values in our urbanization variable. So we want to get rid of those so that we're left with complete data. Finally, this takes us to histograms. So what is a histogram? A histogram fundamentally is a type of bar chart that shows the numerical distribution of our data, shows the distribution of a numerical variable, to be more precise. So typically breaks the range of values into intervals that are called bins, and then counts how many values fall into each bin. So it's helpful to look at histogram because it allows us to understand what our data looks like and also where most values are located. So let's imagine, before we delve into the life expectancy urbanization data sets, let's imagine we have SAT scores. So these could range. So let's imagine we have one student that has scored somewhere between 400 and 800. We have four students that scored between 800 and 1200. We have five students that scored between 1200 and 1600s, and so on and so forth. So we have a number of students that have these scores. So let's imagine that we have all these students in this value. On the line, you have the precise scores that each student got. And then we have these intervals. We have 400 to 800, 800 to 1200, and so on and so forth. You can see that this is one observation. This is four observations. So one student, four students, five students, three students, and two students. Okay, now to take into account and to see them more clearly where they are, we can create these bar plots. So notice how all these students turn into bars. Finally, for the final step of the histogram, we also label our axes. So on the one hand, on the x-axis, we have the SAT score bin. Remember, a bin is a specific interval. So in this case is 400 to 800, 800 to 1200, 1200 to 1600s, 1600 to 2000, and 2000 to 2400. And then on the y-axis, we have frequency, meaning how many people got scores that fall within those intervals. Okay, now we can apply this knowledge or this toy example or the logic behind this toy example to our data. So let us first do this type of histogram manually. So how do we do that? Let us first round our life expectancy mean. Remember that this variable was simply the average life expectancy by country, right? So imagine you have Afghanistan, 1950, 1951, 1952, all the way to 2021. Rather than having 71 values, you're just going to have one. But you're going to have, for example, Afghanistan 52.5. Rather than having 52.5, we want to have 53. So that is precisely the point of this piece of code. Remember, this is the data frame, the merged data frame. This is the average life expectancy. And then this is the part of the code together with this that rounds the value. So rather than having a decimal, like 51.5, we're going to have 52 as a result of this code. So then we're creating this new variable called life expect mean underscore rounded that is part of this final data set. So notice, for example, as a result of this round 0, notice how this 70.259 turns into 70. Similarly, notice how 45.38 turns into 45, and so on and so forth. So we're doing the same thing for urbanization. So if you want to see urbanization, you can just move here, and then urbanization to 4805 turns into 48. Here's an interesting example. 18.61 turns into 19. So this is because if it's everything that has a decimal point above 0.5 becomes, you're allowed to round up to the next big number. So 18.6 turns into 19. Okay. So the next step is to create a frequency table. So we just rounded our numbers. So now we're going to use table. right? So table allows us to, so this is the life expectancy mean rounded. This is the rounded value that we just created. This is the data frame. Remember that the dollar sign is really the thing that allows you to access a specific column within a data frame. And this table function allows you to create a frequency table. So the frequency table looks more or less like this. So these are all the values in our data frame, and these are the frequencies. So what does this mean? There's only one country where average life expectancy is 38. There's two countries where average life expectancy is 43, three countries where it's 44, four countries where it's 45. Notice four countries where it's 46, five countries where it's 47, five countries where it's 48. So this is not just an ordering of data, but rather this is the count, right? So how many countries life expectancy, for how many countries life expectancy is 38, for how many countries life expectancy is 43, and so on and so forth. Okay, so let us turn this into a data frame because this is just a table object. So we want to turn this into a data frame. As we know already, we can simply do this by writing data.frame. So this is going to allow us to see our data frame on the right-hand side. The only thing, so remember that if we look at, for example, urbanization or original urbanization data frame, we have column names such as entity, code, year, and this ugly variable name. For the frequency table, we have var1 and frec. So essentially, var1 will be this, and frec will be this. But this is clearly not the most helpful labeling. So the way to change these column names is to simply write names, the name of the data frame, and one. Remember that this is a way of indexing to refer to the specific items within a vector, because names frec table has two items, these two, we can specifically change them. So if we just type in names frec table 1, this is just going to return var1. If we say instead of var1 associate this name, this is going to replace the item name. So this is exactly what's happening with the second line. And then just in case this might be a numeric variable, a string variable, we want, or maybe even a factor variable, we want to make sure that we are dealing with a numeric variable, because this is going to allow us to plot this into a graph. So this is the point of this part here. So we have the data frame, frequency table. We have this rounded value that we calculated earlier. Remember, the dollar sign is a way to access a variable within a data frame. We first turn this into a string variable, and then we turn it into a numeric variable. The reason why I'm doing both is to deal with the possibility that this might have been mistakenly been turned into a factor variable. So in order to turn a factor variable into a numeric variable, we have to have these two steps. And of course, if you're not dealing with a factor variable, this is not going to do anything to the data. It's going to maintain it as numeric. Then I'm keeping it as is. So I'm just simply replacing the old life expectancy rounded to, I'm keeping it. I'm just replacing the old one with the numeric variable. And then just to confirm, we have 35 observations and two variables. Those two variables are called life expectancy rounded and frequency. So this is because of these two steps, the first steps and the second step. Otherwise, this and this would be called var1 and frec. So that is the point of performing this step. So just to confirm once again, these are the new variable names, and this is what they look like. Once again, the new data frame captures how many countries have a life expectancy of 38, how many countries have a life expectancy of 43, how many countries have a life expectancy of 44. And you can clearly see them here. Okay, this is what our data looks like as a histogram. So on the x-axis, we have all these different ages. On the y-axis, we have frequency. So if you remember from this table, we have one country where life expectancy is 38. Here it is. This should be 39, but we do not have any country that's with a life expectancy of 39. The next one is 43 with 2 observations, meaning there's 2 countries in our data set that have a life expectancy of 43. Here it is. These are the 2 countries. The next one, we have 3 countries where life expectancy is 3. Here they are. And then we have 2 age groups that have the same count, 4. Here they are, 44, 45, and 46. So hopefully this is intuitive now. This is literally this table as a bar plot. This essentially shows how many times different values can be encountered in our data set. How do we produce this graph? Simple. First of all, we load the library. Remember, this is ggplot2, not ggplot. We take the data frame, in our case, it's called frec table, and we say specifically, this is what our x should be. So this is life expectancy mean rounded. And this is what our y should be. So this is y, and then the x is the horizontal axis. We have to do this geom bar identity, that's just standard. We have to, in order to produce a bar plot, we want to make this black and white. And then what I want for better display, I want to create limits to both the x and y axis just to better show the data. But obviously those are optional. So if you click on show the code, you can simply copy and paste this code in your own Quarto document and replicate exactly this graph. Okay, guess what? This was a lot of work, like creating rounding the numbers, creating that table of frequencies, but R kind of does it on the fly. So how does it do it on the fly? By using this geom histogram function within ggplot. So notice how similar these two are. They're not exactly the same, but they're similar. So rather than calculating that frequency table, you can also just do this. The data frame, you specify what the x is. Here you don't need to specify the y because you're using geom histogram that automatically takes the frequency into account. And then these other optional fields that, make the background black and white and that specify the limits of the x and y axes. So if you just do geom histogram instead of geom bar identity like here, right? But notice that I'm not using frec table in the second. So in the first graph, I used frec table, which was the frequency table that I created. And this one, I'm using the merged data. So I'm using the original data set before calculating the frequency table. So the point of showing you both methods is precisely to understand better, to get you to understand better what a histogram is and what it does. Okay. With geom histogram, you can control the bin size. Remember, the bin size is really the interval. You can say, okay, I want all the countries that have life expectancies between 38 and 45 in the same bin. But you can also say, I want all the countries that have life expectancies between 38 and 55 within the same category. So this is a bin size of 50. So we can specify the bin here. Bin equals 50. You can also specify here COL equals white. As you might imagine, this is the thing that specifies the white gaps between the bars. So this is a bin size of 50. And this is a bin size of 35. Hopefully you see the difference. So if you do 35, that means the the bin widens. Okay, so this is what they look like side by side. So this is the frequency table, and this is the histogram, right? So very similar, but still a bit different, right? Because this is where the R calculates automatically the size of the bin. So in practice, you never have to, you probably shouldn't do the frequency table on your own. You should just use geom histogram. But again, the point of this was to show the mechanics behind a histogram and to understand better what a histogram is and to understand the logic of a bin conceptually. Okay, so remember that the mean shows us the average value of a variable. So this is simply calculated like this. So x bar, x1 plus x2 all the way to xn divided by n. This is also written as x bar. So this is the mean. This weird symbol here is the sigma notation that defines the sum. So remember that this is how we calculate the mean, right? So this is our data frame, and this is our variable of interest. DNA.rm allows us to remove any NA values. So our mean life expectancy is the 61.26. So this is how we can display it in our graph. So we still have the geom histogram with 35 bins, but now we're adding this geom V line. So this is going to allow us to plot the mean exactly in the middle of the histogram. And then I'm also annotating it. So feel free to skip this step if it feels a bit difficult to comprehend. Essentially, I'm trying to write in red, mean, right? So in order to annotate this, I have to be specific about where I want this this annotation to appear, but I wouldn't worry too much about it. So if you run this, you will get a graph that looks like this. So very helpful. So we have on the one hand the histogram with the 35 bin, and then we have the mean here, right? The mean x bar, which is 61.27, which is the one that we just calculated. So this is very helpful because we understand how the data, where the data centers. Like the histogram fundamentally tells us about the spread of our data. Okay, the median, as we learned already, is the middle value in our data set. So just a recap. So if we have an odd number of observations, this will be exactly the middle number. So for example, if we have 137, the median will be 3. But if we have 1357, the median will be 4. So why is it 4? Because we add these two numbers and then we divide them by 2. So 3 is the second value, 5 is the third value. So 3 plus 5 divided by 2 will be equal to 4. So in our case, this is how we calculate the median. Notice that here I decided not to use the NA.rm equals true, but I'm lucky because I don't have any NA values in my data. If I had, this would be NA here. So just to be cautious, I encourage you to always use NA.rm equals true. So here's, for example, how we also paste the median in our graph. So remember that previously we had the mean, this is it. And this is how we also add the median. And then this is how we annotate the two elements. And this code allows us to get a graph that looks like this. So we have the mean here depicted in red, and we also have the median depicted in blue. So it's very helpful to see how far the mean and median are from each other. Okay, here's another way to display the spread of our data. This is done through what is called the box plot, which you can clearly see after the histogram. So how do we read the box plot? Here's how we read it. This thick line here corresponds exactly to the median. The ends here correspond to the 25th and the 75th percentiles. And then the gap between the 25th and 75th percentile is called the interquartile range, right? And then all the other sections represent the minimum. So this 25 minus 1.5 multiplied by the interquartile range. And then the opposite here, 75% plus 1/5 times the interquartile range. So this is how we transfer what we know about a histogram into a box plot. And hopefully this is also informative about how to read a box plot and how this also is very similar to a simple histogram. Okay, standard deviation is also another important concept. So standard deviation is the square root of the variance. This is what this sign represents. So this gives us the average distance of our data from the mean. So to calculate a standard deviation, we're simply doing this. So the data frame and then the variable that we're interested in. And then here, I am creating something specific for the graph itself. I would like to illustrate the standard deviation concept in relation to the mean and in relation to the histogram, which is why I'm creating the sequence for the axis x from -3 to 3 multiplied by the standard deviation value. And then I'm also creating labels, sigma labels. So I'm removing the median for now, the label for the median, and I'm just now adding these sigma breaks and these sigma labels. So this is what this gives me. So don't worry too much about the code. If you just simply copy and paste this, obviously after you copied and pasted this, you should be able to obtain the graph. The point behind this is to mostly show you conceptually how the standard deviation is connected to the mean and the distribution of our data. So in the background, you have the histogram that we produced a few times now. In the middle, we have the mean. We calculated multiple times. And these are standard deviations. So this section here represents one standard deviation away from the mean in a negative direction. This also is one standard deviation away from the mean in a positive direction. This whole section here are two standard deviations away from the mean, whereas this section here represents two standard deviations also away from the mean, but in a positive direction. Hopefully you find this graph informative and helpful. Okay, so we have covered a few concepts. So the most important one here is this notion of a histogram that really tells us the distribution of a variable. It shows us what the distribution of a variable is, how spread it is. So bar plots are helpful in order to visualize frequencies of discrete or grouped data. We also looked at the mean and median and how they're reflected onto a histogram. We also looked at the standard deviation, which kind of tells us how spread out the values in a histogram are. Thank you and see you in the next video. I hope you enjoyed this video. If you found it helpful, please give it a like and press subscribe. Also, if you have any questions or comments, feel free to leave a comment down below. Thank you and see you in the next video.